Hello, my name is Peter Brummel, and today I'm excited to talk to you about how to balance a chemical equation. First, we're going to see what a chemical equation is and why they need to be balanced. So what is a chemical equation? Basically, chemical equations are the written expression of a reaction. So right here we have C, or carbon, added to oxygen converts into CO2, or carbon dioxide. Now these little subscripts here, like this 2 here, tell us how many atoms there are in an oxygen molecule. There are 2 oxygens bonded together. And in this carbon dioxide, there's 2 oxygens bonded together and bonded to a single carbon. We can tell just one because there's no subscript there. Now there are 2 parts to a chemical equation like this. There's the reactants on the left side of the arrow and the product on the right side of the arrow. Now the reactants are the things that come together to form the product, or maybe disassemble and reassemble in a different way. So here we have the reactants are carbon and oxygen, and the product of their reaction is carbon dioxide. Well, what would this actually look like in real life? By using a ball and stick diagram, we can see. Here we have a carbon atom, and it's joined to this oxygen molecule. And when that happens, it turns into a carbon dioxide molecule where all 3 atoms are joined together. Now, why do we need to balance chemical equations? We need to balance them because of a principle or law in science called the principle of mass conservation. Now, this principle says that matter cannot be created or destroyed. Applying this to chemistry means that we have to have the same amount of matter before and after the reaction, because if we don't, matter is just disappearing in thin air, which goes against the law of mass conservation and is not what happens in real life. This is an unbalanced equation. You can see here we have 2 nitrogen atoms and 2 hydrogen atoms, and they're coming together to form this NH3 molecule. The problem with this equation is that while we have 2 nitrogen over here, we have only 1 over here. And while we have 2 hydrogens over here, we have 3 over here. So it looks like one nitrogen molecule spontaneously disappeared and one hydrogen molecule miraculously appeared. So it looks like one nitrogen molecule spontaneously disappeared and one hydrogen molecule miraculously appeared, which is very unrealistic. So what could we do to balance this? Now, some people might think that you could just put a subscript between the N and the H and put a 2 there, and then erase this 3 and put a 2 there, and that way you'd have N2H2 and it'd all be balanced. Problem is, this molecule formed by the result of that reaction is totally different. It's no longer this NH3 molecule, it's this N2H2 molecule, which is not the product of the reaction we were just looking at. It's a completely different reaction. And so you cannot add subscripts. There is something else you can do. You can add a number in front of a chemical, which will tell you how many of that chemical there is. Let's see an example of that. So here we have our reaction, and to add a number in front of it, we could put a 2 in front of the NH3. And now, instead of just one NH3 molecule, we recognize we actually have 2. And that balances the number of nitrogens we have, because over here we have 2, and now we have 2 over here. But that also adds 4 hydrogen molecules, and so we got to account for those, which is pretty easy. So what we can do is put a number in front of this hydrogen, which would make it add up to 6. So we're going to put a 3 in front of that hydrogen. So now we have 3 H2 molecules, and 3 times 2 makes 6. So you just take this number times the subscript. That's the number of atoms you're going to get out of that. And now you can see the equations are balanced. We have 2 nitrogen, 2 nitrogen, 6 hydrogen, 6 hydrogen. Let's see another example. Here we have carbon combining with an H2 molecule turns into a CH4 molecule. The problem with this is that in the beginning of the reaction we have 2 hydrogens, while at the end we have 4. And so it appears to be spontaneous hydrogen formation. So what can we do to correct this equation? Well, we can add a 2 in front of the H2. So now we have 2 hydrogen 2 molecules. So now we have 4 hydrogen in all on both sides of the equation, and the equations are balanced. Let's see another example. Now rather than drawing it out in this example, I'm going to have this little chart here. And I've written the number of atoms of each element we have before and after the reaction. So to start with, sodium is balanced. We have 1 sodium on each side. Chlorine is not, though. We have 2 on the left side, 1 as the product. So how can we balance that? Well, we can put a 2 in front of the NaCl. And that makes it so that we have 2 chlorine on this side and 2 chlorine on this side. But that throws off the number of sodium we have now. So we can put a subscript in front of the sodium, and now everything is balanced. We have 2 sodium on this side, 2 sodium on that side, 2 chlorine on this side, 2 chlorine on that side, and everything is balanced fine. Let's see one more example. Here we have CH4 plus O2 changes into CO2 plus H2O, quite a large equation. So here, once again, I've charted the number of atoms before and after the equation. So to begin with, we have just carbon is balanced, and hydrogen and oxygen are not balanced. But if we put a 2 in front of the H2O, we can get the hydrogen and the carbon balanced, and to end, we can put a 2 in front of this O2 and have the oxygen balanced as well. You can kind of see I've worked down here. So, I hope you've learned how to balance a chemical equation and can do it on your own now. Please subscribe to our channel to get some more videos about chemistry. Thank you.